Welcome to Notes 7-1 for Integrated Math 3. We're on page 93 from the book. So we're on page 93. And this is on inverse functions. So inverse functions, let's talk about what inverse means. An inverse is, like algebraically, is the undoing or the opposite of an operation. For example, the inverse of a square root would be squaring, right? So something like the inverse of a square root is to square it, or the inverse of multiplication is division, and so on. So today we're going to be working with inverse functions. So our learning targets are to find the inverse of a linear or quadratic function and to write an inverse function using the proper notation. Okay. All right, so it says two functions, f and g, are inverse functions if and only if. This notation here, this is called a composition of functions, and we've done that back in Math 2. And basically what this means is I'm going to take g of x and substitute it into f of x. And so it says f of g of x is equal to x for all the domain of g, and g of f of x is equal to x for all x in the domain of f. And so this right here says you can use compositions of functions to verify that two functions are inverses, of one another. Right, so it says to verify by composition that f of x and g of x are inverse functions. Okay, so it says the first step is to substitute g of x into the function f of x. So I'm going to do that off to the side. I know they've done it for us, but it's helpful to see it done. So I'm going to take g of x, which is x plus 2 over 3, and I'm going to substitute that into f of x. So I'll start by writing f of x, 3, and then instead of putting my x, minus 2, right? So this was 3x minus 2. Instead of putting x, I'm going to substitute in this function right there. And so that would give me x plus 2 over 3. All right, then at this point, all you need to do is follow the order of operations. So the order of operations is to simplify the parentheses, but it cannot be simplified. So then the next step would be, I could just multiply. I see that these 3's will reduce out. And so I'm left with x plus 2 minus 2. I don't really need these parentheses anymore. I can drop them. X plus 2 minus 2. And positive 2 and negative 2, they cancel out, and I'm left with x. So I just verified that f of g of x is equal to x. Now I have to do the same thing for g of f of x. So I'm going to do that down here. So g of f of x. This time I'm going to start with the g, right? So I always start with my outside function. I've started with f here. I'm going to start with the g here. I'm going to write my outside function, which is x plus 2 over 3. But rather than putting an x right here, I'm going to substitute in this function, 3x minus 2. So I have 3x minus 2 that I'm substituting in. So this was x plus 2 over 3. And rather than writing the x, I'm putting in the other function. All right, now we're going to follow the order of operations. I'll go ahead and simplify my numerator. That gives me 3x minus 2 plus 2 over 3. And these 2's cancel. So I have 3x over 3, and the 3's reduce to a 1, and that leaves me with x. So I just verified that these are inverse functions, because when I compose f and g, or g and f, I result in x. All right, so there's some try these. We're going to do a couple more examples. They give us f of x is 2x plus 8, and g of x is 1/2 x minus 4. So I'm going to find f of g of x. And to do that, I start with my outside function, which is f. So 2x plus 8. And I'm going to substitute in g. That's 1/2 x minus 4. There's nothing to simplify inside the parentheses, so I can distribute through. That gives me 2 times 1/2 is 1, or 2 over 2x. And then minus, I'll distribute, that becomes 8, and bring down my positive 8. 2 over 2 reduces to 1. Negative 8 and positive 8 reduce, and I'm left with x. I'll do the same thing for g of f of x. This time I'll start with g, so I'll write my g function, 1/2 x minus 4. All right, 1/2 x minus 4, and instead of putting x here, I'm going to substitute in this entire thing, 2x plus 8. Again, following the order of operations, I'll distribute through, and when I distribute half of 2, right, or 2 over 2, it's going to become 1. Half of 8 is positive 4, and then minus 4. This reduces to a 1, and these cancel out to 0, and I'm left with x. So I have just verified that these are inverse functions of one another. All right, we're going to do one more. We're going to do this one. I'm going to do it on a separate sheet of paper because I'm out of room. I think I can squeeze it in down here. All right, I'm going to squeeze it in down here. So we've got f of g of x equals x cubed, right? So I'm starting with my f function. My f function is right here. And my g function, I'm going to substitute it in. My g function is the cube root of x. And as we saw yesterday in the warm-up, the getting readies, square roots and squares are inverses of each other. Same thing with cubes. Cubes and cube roots, they undo one another, and so I'm left with just what's under the radical, which is x. And I'll do the same thing again with g of f of x. And this time I'm going to start with my outside function being g. My outside function is the cube root of x. But x that we're going to substitute in is f of x, which is 3. And again, cubes and cube roots are inverses of one another, and we are left with x. So we've just verified that these are inverse functions, these are inverse functions, and these are inverse functions. All right, moving on, so flipping it over, it says explain how to verify that two functions, h and g, are inverse functions. So explain, so you would find both g of h of x and h of g of x and verify that their compositions equal x. Okay, next it says to determine whether k of x equals x plus 3 and m of x equals 3 minus x are inverse functions. Explain your reasoning. So I'm going to compose these functions. I'll do that up here so that I can leave room for this example. So k of m of x equals so I'll start with my outside function k. It's going to be x plus 3, and I will substitute in 3 minus x. I can see that when I do this, I get negative x plus 9, and I can stop at this point because I see that these are not inverse functions. So they're not inverse functions, no, because k of m of x does not equal x. All right, we're going to go on to the third one. And the third one says, given that f and g are inverse functions, explain how you can find f of g of 0 without knowing the equations, or sorry, f of g of 20 without knowing the equations for f and g. Well, if they're inverse functions, we know that f of g of x will equal x. Therefore, f of g of 20 will equal, well, what's your guess? X and x, 20 and 20. All right, let's go on to example B. Oh, it says the function notation f inverse denotes the inverse of a function f and is read f inverse. To find the inverse of a function algebraically, you're going to interchange the x and y variables, then solve for y. So that's our function, and we're being asked to find its inverse. The first thing that I'll do is I will rewrite this f of x equals 2x minus 4. I'm going to rewrite that using y. It just makes my notation a little easier. It says the next thing that we're going to do, so it says to let y equal f of x. So we did. I changed out y with f of x. And then it says interchange the x and y variables, meaning switch x and y. So I'm going to rewrite it, and this time I'm switching. I'm putting x in place of y and y in place of x. And then it says to solve for y. So I'm going to solve for y. To solve for y, I would add 4 to both sides. And that would give me 2y equals x plus 4. I would divide both sides by 2. My 2's would cancel here. That would give me x plus 4 over 2, which is equal to y. Now you can also write this in, like, say, slope-intercept form, where you put your slope as 1/2 and your y-intercept is 2, but you don't need to. You can just leave it like this. And then finally, with the proper notation, we're going to say, remember that y is actually f inverse of x, and that equals x plus 4 over 2. So we're going to rewrite with the proper notation. Y is going to be f inverse of x. All right, it says to find the inverse of each function. I'm going to do the first couple down here, and then I'll probably have to switch over to another page with some more room. So A, f of x equals negative 3x plus 8. The first thing I do is I rewrite this using y. Right, rewrite using y. Next, I'm going to switch x and y. So again, I rewrite using y. Then I switch x and y. And now I'm going to solve for y. So I'll subtract 8 from each side. That gives me x minus 8 equals negative 3y. Divide both sides by negative 3. And I get y equals x minus 8 over negative 3. We generally don't leave negatives in the denominator. What we generally do is we write them out front. So this is the same as negative x minus 8 over 3. And then we're going to use our proper notation. So my final answer will be f inverse. So this is for A, f inverse x equals negative x minus 8 over 3. All right, let's try the next ones. I'll do those on a separate sheet of paper. So for B, all right, B says g of x equals 1/4 x plus 12. So first I'll rewrite using y. Next I will switch x and y. Then I'll start to solve for y. So you can either distribute through, or you can go ahead and get rid of the 1/4 by multiplying both sides by 4/1. The 4's will cancel, the 1's also. So I get 4x equals y plus 12. No need for those parentheses. Subtract 12 from each side, and we get 4x minus 12 is equal to y. Rewriting this with proper notation, I'm going to rewrite it as f inverse x equals 4x minus 12. All right, let's do the next one. Try these c. So for c, our function is h of x equals, oh, I'm sorry, this should be a g. I forgot, right, that we were using g. So not f, this is going to be g inverse of x. Right here, I forgot that we were using g, right? So g inverse. All right, h of x equals 2/3 x minus 5. So I'll rewrite this using y. And then I'll multiply by the reciprocal to get rid of this in just a moment. First, I'll go ahead and switch my x with my y. So x equals 2/3 y minus 5. To solve for y, I'm going to add 5 to both sides. That gives me x plus 5 equals 2/3 y. And this is where we'll multiply by the reciprocal. The reciprocal would be 3/2, and those reduce. I have to multiply this side by 3/2. And so that would be 3x